Hi everyone, this is a presentation on our project EXCELsior. So the motivation for this project is that Excel is a very popular and widely used tool, especially among engineers. It's used to store data, which acts kind of like a lightweight database. Uh, the problem is that it isn't easy to write complex queries to get the specific data you want across multiple different sheets. A possible solution would be to convert these sheets into a graph database. So our solution is a wizard that allows users to write complex queries to these databases. The benefits is that the users don't have to directly interact with their database, as our database converts the data into a CSV file that is more familiar for the users.
As for our application landscape, our application uses an n-tier landscape. We have our front-end web page and our back-end, with the database kind of acting as a third tier. As for our application structure, we have three different layers: our client, our website, and our database server, with the website having three sub-layers: business logic layer, UI layer, and data access layer. Our user interface follows an MVVM model because of our use of React. Here's our design. While our application doesn't actually use any classes, a lot of the endpoints and the applications themselves kind of act as classes, which is why we're able to build this model. Our application uses a facade pattern in a way. It acts as the facade itself for our user to updating and querying a database.
For implementation on our project, we went with fairly standard choices for web application using JavaScript and the Node.js environment. On the front end, we used the React library for building UI components, as well as the Axios library for making HTTP requests to our backend, as well as several other component libraries for React just to have some pre-built components. On the back end, we use the Express framework with some specific libraries for working with the Sparkle backend. The Sparkle HTTP client is a library specifically for making queries to a Gina Fuseki Sparkle database. The JSON to CSV is for converting our JSON responses to CSV files. Multer is for accepting files uploads from the front end, and cores is so that the front end can communicate with the back end. For test strategies on the back end, early on we were mostly concerned with learning the Sparkle query language, and so we did a lot of testing just using the Fuseki interface to the Sparkle database. Once we figured it out and had that working, we were able to move on to Postman for testing API requests both to our own backend as well as the Sparkle server. For the front end, it was mainly just communicating with the back end, so we mostly did hand testing for the UI elements.
Our CI/CD process is quite simple. We just set up a GitHub action, which essentially spins up a container running Node, which pulls our code and then tries to build our node, and also tries to build a React, and just does like some very basic tests to check that they're working properly. And this adds an extra layer of security to our GitHub pull and push request. So yeah.
This is going to be a quick demo of the front-end application of EXCELsior. So first is the download part, and what we're doing here is querying a graph database and downloading our data in the form of a CSV. We can input a database URL here. Next, you're going to be prompted to select a class, just given your URL. I'll select this one. And it'll then ask me to select some attributes that I would like to see. I'll click 4 of these and go next. From what you've essentially done, you have a summary page of your database, the class you're looking for, as well as the attributes you want to see. If you download results, you'll get a download file, and if we open it up, we can see that we just get a pretty large table of all the data we're looking for, with the ID and attributes being the headers of the table. Next, there's finish, so this will redirect you back to home. And we can begin the upload part. What we're doing here is uploading a CSV to update or add some values into a graph database. I'll select this file, which is a one-liner, but will update something in our graph database that we'll provide later on. Next, just given the file you upload, you'll be given opportunities to provide labels. However, this part is entirely optional. Next, all you need to do is provide your endpoint URL. And you'll get a summary of your database endpoint, the file you want to upload into it, and any attribute mappings, if any. If you click update, you'll get a ping from the server that says it's been updated. We can also take a look at our developer tools and see that a update with a success status is able to go through. And if you click finish, you'll be taken back to home, and that's our application. Thank you.
In terms of our Scrum process, our team did 3 2-week-long sprints. We had weekly meetings to discuss implementation progress, to review our code, discuss any sort of issues we may be having. Myself, Jaime, I served as the Scrum Master / project manager. My job was to make sure we were on top of our project, to streamline the process, assign issues, just more or less keep everything organized. Alonso was our main front-end developer. Bryce was our main back-end developer. Shri helped both with front-end and back-end. And Matan was our main tester, and he also helped with back-end. In terms of our sprint statistics, we had 3 epics: web application or our front-end, app functionality for our back-end, and our final product, which was the integration of both the front end and back end. In terms of our stories, we had 10 for web application, 4 for app functionality, and our final product was just composed of the 2 other epics. We had 55 total tasks that were split up between the 14 stories and the various epics. And we learned a ton of lessons in this project, the main one being time estimation for tasks. We found that a lot of our tasks ended up rolling over to the next sprint just because we weren't able to time ourselves correctly. In terms of next steps, we essentially want to be able to make this perform more complex queries. As it stands right now, the application is very simple. So the next step would be to improve the amount of queries as well as customizability that we can generate with this application. Thank you. Any questions?